Hey everyone, and welcome back to Collapsed Latents. This week in AI, your weekly deep dive into the most mind-blowing breakthroughs shaping the future of artificial intelligence. I'm your host, and this week, we're not just watching AI evolve. We're watching it think. From AI that judges science like a peer reviewer, to models that plan across denoising steps like a human mind, to open-source search agents that beat giants with just 11,700 carefully crafted questions, and more. This week, AI isn't just generating content. It's reasoning, evaluating, and even inventing with scientific taste. So grab your coffee, hit subscribe, and let's dive into the 5 most groundbreaking AI papers of the week. Because the future of intelligence is no longer just what AI does, it's how it thinks. 1. The rise of scientific taste, when AI learns to judge what matters. What makes a great scientist? Is it raw intelligence? Years of training? Or is it something deeper, something intangible? It's not just about knowing facts. It's about judging which ideas are worth pursuing. Which ones could change the world? Which ones might be brilliant, or just cleverly disguised dead ends? We call it scientific taste, and now AI is learning it. Enter OpenMOSSAI, a system from Fudan University that doesn't just read papers, it understands them. Like a real scientist. Here's the twist. Instead of relying on keywords or citation counts alone, the team built a massive dataset of 700,000 paper pairs, matched by field and year, and asked a simple question: which one is more likely to be impactful? The answer: real citation patterns. The scientific community's quiet vote. They trained a model called Scientific Judge, not to memorize but to reason. It asks, does this idea generalize? Could it become a standard tool? Is it solving a persistent problem? And the result? It outperforms even GPT-5.2 and Gemini 3 Pro by a significant margin. But the real magic: generalization. It predicted high-impact papers after training. It understood peer review preferences. It worked across math, physics, biology, without being taught each field. And then came the kicker: scientific thinker, an AI that doesn't just judge but creates. Given a paper on reinforcement learning, it didn't just suggest tweaking data. It proposed uncertainty-guided exploration, a method that uses the model's own confidence to probe the unknown. Experts agreed: more elegant, more reusable, more foundational. This isn't about replacing scientists. It's about amplifying human creativity. An AI that doesn't just follow instructions, but inspires them. So next time you read a paper, ask yourself, would an AI with scientific taste have found this idea first? Because the answer might just surprise you. 2. Memory that writes itself, the power of gradient-based memory. Now let's talk about memory, specifically how AI remembers long contexts. Most models use KV cache, a massive buffer storing every past activation. It works, but it's memory-heavy, not portable, and not reusable. Enter GradMem, a revolutionary new approach where memory writes itself, using test-time gradient descent. Here's how it works. Instead of a one-shot compression, GradMem treats a few special memory tokens as writable parameters. Given a context, it performs a few steps of gradient descent, minimizing a self-supervised reconstruction loss. The model sees what it didn't predict well and fixes it iteratively, like a writer revising a draft. And the results? On a synthetic associative retrieval task, GradMem with just 8 vectors achieved 96% accuracy on 96 key-value pairs, far outperforming forward-only methods that max out at 1632. But it's not just synthetic. On real-world tasks, BABI, SGAD, Wikitext, GradMem matches or beats top baselines. On SGAD, it hits 54.9% exact match with just 5 gradient steps. And here's the trade-off: pay more compute at write time, save it at read time. Once the memory is written, every query is fast, because you're attending over a few vectors, not thousands. This isn't just compression. It's writing with feedback. A memory that learns what to keep, what to fix, and why it matters. And it opens the door to agents that reason over code bases, dialogue systems that remember context, and models that think across long, complex inputs. The future of memory isn't static. It's dynamic, adaptive, learned. 3. OpenSeeker, the search agent that beats giants without a billion-dollar budget. Now let's talk about search, specifically the most powerful AI search agents. For years, this space was dominated by tech giants. OpenAI's O1, Google's Gemini Deep Research, Alibaba's Tangi. All closed source. All with massive data moats. But what if you could build a frontier agent with no billion-dollar budget? Enter OpenSeeker, the first fully open-source search agent that beats industrial giants on equal footing. How? By rethinking training data. Instead of scraping the web, the team reverse-engineered real web graphs. They started with seed pages, followed links, built dependency subgraphs, extracted entities, and generated complex multi-hop questions, obfuscated to prevent keyword cheating. Then they introduced denoised trajectory synthesis, a two-phase cycle where a teacher model sees raw web responses, then summarizes them into clean, semantic abstractions, like 3 competitors with different pricing tiers. The student, it sees the raw data, and must learn to extract the signal from the noise. The result? A dataset of just 11,700 high-difficulty QA pairs, in English and Chinese. And the performance? Staggering. On BrowseCompCH, 48.4% beating Tongyi Deep Research. On Xbench Deep Search, 74.0%, surpassing OpenAI's O3 and Claude 4.5 Sonnet. On Wide Search, 59.4% F1, outperforming models with 10x more data. All with one SFT run. No RL. No hyperparameter tuning. This isn't just a model. It's a paradigm shift. It proves that data quality trumps data quantity. And that a single academic team can beat industry giants by building smarter, not bigger. The code, data, and model are all open. On Hugging Face. On GitHub. The era of closed, opaque search agents. It's over. The future is open. And it's already here. 4. Chain of steps, when video models reason across denoising steps, not frames. Now let's dive into video generation and what's really happening inside these models. For years, we thought video models reasoned frame by frame, like a story unfolding over time. But new research reveals a stunning truth. Reasoning happens across denoising steps, not frames. We call it chain of steps, CoS, a fundamental shift in how we understand machine intelligence. In diffusion models, at each denoising step, the model doesn't just generate pixels. It explores multiple paths simultaneously. Imagine a robot solving a maze. At step 0, it generates 2 plausible routes. As denoising progresses, one fades, the other strengthens, until only the correct path remains. This is multipath exploration, a form of parallel reasoning built into the architecture. Even more fascinating, superposition-based exploration. In spatial tasks, the model superimposes multiple hypotheses, overlapping circles, blurred rotations, all coexisting in the latent space, before resolving into a single solution. To test this, researchers injected noise at the step level versus the frame level. Perturbing a single diffusion step caused performance to plummet from 0.685 to below 0.3. But corrupting a single frame? Minimal impact. Why? Because diffusion models use bidirectional attention, they can reconstruct corrupted frames from others. But disrupt the reasoning trajectory, and the whole chain collapses. So the real engine of reasoning. It's not the frames. It's the steps. And within those steps, 3 behaviors emerge. Working memory, the model remembers objects even when occluded. Self-correction, it revises trajectories, refining physics and motion. Perception before action, it identifies objects before deciding how to act. Even more powerful. A simple training-free trick, latent path ensembling. Run 3 forward passes, average the middle layer latents, and get a 2% boost on video reasoning benchmarks. This isn't just insight. It's a blueprint. We can now steer the model's reasoning, like a cognitive architect. And the implications. Video models aren't just generators. They're reasoning engines, planning, correcting, exploring futures, just like the human brain. 5. MOCR, when charts become code and documents become intelligence. Finally, let's talk about documents. Traditional OCR. It sees text. It ignores charts, diagrams, UIs. It treats them as inert images, detected, cropped, discarded. But what if we treated everything on a page as a first-class target? Enter multimodal OCR Mocker, a system that parses not just text but code. Instead of returning a cropped image of a bar chart, MOCR generates SVG code, a machine-readable, editable, scalable vector file. This isn't just better fidelity. It's a new source of structured supervision. Every parsed chart becomes an image code text triple, perfect for training multimodal models. The team built DOTS, Mocker, a 3 billion parameter model trained on PDFs, web pages, and native SVGs, using render-based verification and canonicalization to ensure code renders faithfully. And the results? Stunning. On document parsing benchmarks, 83.9 on OpenMOSSAI bench, second only to Gemini 3 Pro. On image to SVG tasks, 0.902 on Uni SVG, beating even closed-source models. It reconstructs scientific figures, UI layouts, chemical diagrams, accurate, editable, reusable. And it's not just good at parsing. It holds its own on general vision language tasks, showing that unifying document understanding with broader VLM training enhances general capability. This is more than OCR. It's a new paradigm. Documents aren't just sources of text. They're executable knowledge. And MOCR turns them into a scalable, programmatic training ground for the next generation of AI. The future of multimodal AI. It's not just seeing. It's understanding the full visual language of human knowledge. So what's the big picture? This week, AI didn't just get smarter. It started to think like a scientist, judging impact, not just output. It learned to write memory with feedback. It built search agents that beat giants on open data. It revealed that video reasoning happens across denoising steps, not frames. And it turned static documents into dynamic, executable code. The thread. Intelligence isn't just in the model. It's in the process. In the way it reasons, corrects, plans, and learns. And the most exciting part. This is just the beginning. So if you're a researcher, a builder, a dreamer, go build. Download OpenSeeker. Fine-tune MOCR. Experiment with GradMem. Explore CoS, because the future of AI isn't locked behind corporate walls. It's open, it's collaborative, it's yours. Thanks for watching. If you enjoyed this deep dive, hit like, subscribe, and drop a comment. What paper will define the next decade? Until next time, keep questioning, keep exploring. This is Collapsed Latents, This Week in AI. See you next week.